A radioactive isotope has a half-life of 10 years. How long will it take for the activity to reduce to 3.125%? One radioactive isotope is there. It will reduce a half-life, that is, it will take 10 years. And in that process, how long it will take for the activity to reduce to 3.125%? Okay, we need to find the time here. Okay, so they are given t is equal to that is a t half, the half life, t half is equal to 10 years they are given. Okay, and after decay, amount of the radioactive isotope is equal to N. Then 3.125% of N0 remains after the decay. 3.125% of N0 will remains after the decay. Okay. Then N divided by N0 is equal to 3.125%. If I remove the percentage symbol, then it is divided by 100. Then this becomes 3.125 divided by 100, then which is equal to, that is 1 by 32. Then we also know that N divided by N0 is equal to e to the power of minus lambda t, where lambda is the decay constant and t is equal to the time. Then minus lambda t is equal to 1 by 32, because n by n0 is equal to 1 by 32. Then we can simplify this one as minus lambda t is equal to ln 1 minus ln 32. Ln 1 minus ln 32. We know that ln 1 value is equal to 0. Then t is equal to 0 minus ln 32 value is equal to 3.4567 divisible by lambda. Then t is equal to 3.4567 divisible by lambda. And lambda is equal to 3.4567 divisible by t. And here the t is nothing but t half, which is equal to 10 years. Then that t is equal to t half is equal to what? T half is equal to 0.6932 divided by lambda. Then lambda is equal to 0.6932 divided by t half. Then it becomes t is equal to 3.4567 divisible by t half. Then t is equal to 3.4567 divided by 0.6932, and it will come to the numerator, that is 10 will come to the numerator, that becomes 10. Then if we simplify, the approximate answer will becomes t is equal to 49.86. Then the approximate I will take it is equal to 50 years. 50 years is required. Explain the processes of nuclear fission and nuclear fusion by using the plot of binding energy per nucleon versus the mass number A. The second part of the question is, a radioactive isotope has a half-life of 10 years. How long it will take for the activity to reduce to 3.125%? Okay. So here the first part of the question, we'll understand the nuclear fission. Nuclear fission is when a heavy nucleus break into the two medium-sized nuclei. One big nucleus is there. It is broken into a two medium-sized nuclei is what we call as nuclear fission. And the resulting is, therefore, the binding energy per nucleon increases in the releases of energy. That means the resultant is binding energy will be increases per nucleon, increasing in the release of energy. And the second is nuclear fusion. When two small nuclei combine to form a relative heavy nuclei, fusion binding energy per nucleus increases. Okay, and the resulting in release of energy. Okay, this is about the nuclear fission and the nuclear fusion. Okay, and by plotting the diagram, observe the graph here. See, the y-axis indicates the building energy per nucleon and the x-axis indicates the mass number, that is A, mass number A here. Okay, observe here when the binding energy it is increases, when it reaches the stable, the iron Fe, if you observe this one, iron is the maximum number, okay, and increasing the mass number, and iron will get the stable, that is maximum number.